Hello. So I thought today we could talk about functions and tie that in with a little bit with loops. So I thought we can jump into the whiteboard and just have a play around with it. So functions are used when you want to have repeatable pieces of code put into a certain block and stuff that's modular you put into a certain block. So for example, let's say we have a function called play. Oh, that's a bad way to write play, isn't it? Alright, so that's play, even though my handwriting's quite bad in my stencil. You got an open bracket and a closed bracket. You got an open curly brace, and then you got some code written here, and then you got a closed curly brace. Now it's useful to note that anything that's repeatable, again, as I've said, anything that's modular goes into your function. Now, if we go back to our editor, you'll see that we've got two functions already listed. If I can find the mouse. Yeah, there we are. If we can go back, yeah, there we are. So let me get rid of this. We'll go into this a bit more. I was just testing out some examples. So we've got these two functions here, canvas and background. Now, if you drill into these functions even further, you'll find that they have function calls. And if you drill into them further and further, you'll keep going up until you get maybe to bytecode, and then it gets really like low level, and then you have to understand like instructions and stuff. But that's too detailed for what we're covering. Just understand that functions have code written in them that encapsulates certain things that have function calls in themselves as well. Usually they're ways to simplify things or to group things together. Yeah, so let's look at an example why functions are useful. So let's say, for example, we wanted to draw a circle on screen at 100 by 100 by 100. Let's put auto refresh on so we have a look at this. Let's say we want to fill that circle so it is a colourful 100 by 200 by 240. So it has a nice yellowy whatever colour that is. And then you want to put a stroke to it, so let's give it a stroke and let's make it 200 by 100 by 135, which looks funky. Let's make the stroke weight a bit much more than that, so stroke weight. And let's make that 20. What does that look like? Okay, that looks quite nasty. That's a nasty colour combination, isn't it? Let's change that up a bit. Let's make that 40. No, it makes no difference. 200. Oh, that's fine. It's perfectly. Okay, and let's say we wanted to. I'm going to turn off auto refresh because I keep getting into errors in my code for some reason whenever I leave it on. We'll say for let I equals 0, and then we'll say I want to make like a couple of copies of this, so we'll say 5. We'll say I plus plus, so increment by 1. Then we do that. Then we do that. Then we do that. And then we want to get this stuff up. So if we run that, we should have a number of circles created in the same place. If we say 100 times by I, we run that again, you'll have these weird circles dotted from top left to top to bottom right. Yeah? Yeah? Cool. Now what functions allow us to do is we can take all this code away and put this into its own block. So let's say function draw circle, that's not how you spell circle, R goes after the I, and let's put this stuff into that. So let's do Control X to cut it, Control V to paste it, and then Shift Tab. Let's get rid of the I's because that doesn't make sense here, and let's put the function here instead. So we'll call this draw circle, and if we run it, it paints a circle in one place. Okay, but how do we get back the previous behavior that we had? Well, a cool thing with functions is we can pass parameters in. So if we jump back into Paint, you can put a parameter here like I. We didn't really need to jump into Paint, but yeah, you get what I mean. So we can put in the parameter I here and have that call that I here as well. And then we can times that by I. We can times this by I, and then run it again. And then you can see it's got that same behavior where it's going from the top left to the bottom right. Now you might say, what, okay, that's cool, but why would I need to abstract this out into this other function? Well, so let's say we wanted to do something else. Let's say we wanted to go from 4. Let's say we wanted to do the same sort of thing, but we wanted to go in the other direction, right? That way to that way. Now, if we didn't have this function, we would have to copy all this code plus the for loop twice, right? But what we can do here is we can Control C that, Control V, and because let is stored in this kind of block, we can use the same variable again as I. We can say, no, let's not make it diagonal. Let's make it, let's reduce it. Let's say 3, because we're trying to keep this simple examples, right? Let's do that. Let's make this 6. Let's say I has to be bigger than. Okay, so if we say for I equals 6 and then I has to be bigger than 3 and then I decrement, then what we've done here is let's comment this out for a minute so we show it. So we've got top left to the middle, and that's what this function is doing here. And then what we can do here is by allowing that, we've got the bottom right. So what I'm trying to show here with this kind of simple example is that by changing the outer parameters and then passing the same logic into this draw circle, we've created the top right or top left, and then by changing the outer logic and then passing it into the draw circle without changing anything inside this function, we've got the bottom right. And so if we want to make them meet in the middle, we can just reduce this to 2 and then run it, and then there you are. It looks similar to what it had before, but it's a different logic way of doing it. So I'll save that. Now another example I wanted to show was return types. Functions allow you to return certain things. So this example here, which I wrote up previously, was we just have a function called amount. We have an x and y value, so you can pass multiple parameters in. They don't have to be the same value. So for example here, you can just see I've passed the number 5, not even a variable, and then I've made my first parameter. These are called parameters, by the way. The first parameter will be called x, the second parameter will be called y, and then I'm returning the x times the y into a total variable here, and then printing it out to the console. So 5 times 5 is logged 25. Now you can put any number you want. You could put 100 times by 5, 500, there we are. Right, it makes simple sense. Now, this is kind of cool and all, but I thought we could make more, we could try linking this back to loops. So I thought as an example we could try to create a program or a sketch that has squares going in a grid-like pattern, and in each square there's a number of squares in that square. So square inception, if you will. Okay, so this is the final one that I've made. It's a bit complex, but I think it looks kind of cool. It's this. So boxes inside boxes, and they all range from different colors or different variations of bluey green, kind of turquoise color. Now I want to turn it off because it does hurt my eyes a bit. But the general idea is that we draw a background, we have an x and y variable that we created in the draw function, we have a size variable, we have a loop nested inside another loop. Now you might, we've done nesting before where you put an if statement inside another if statement, but there's a kind of cool aspect here where you have loops inside loops. And so what that does is, it goes in here and creates your first one, your first x value, then your second x value, third, fourth, fifth, and goes on. And then for your first x value, which you're here, you then do the other second for loop, which then goes downwards. So think of it like, you do the first one, you then move on to this one, this one, this one, this one, this one, this one, then the inner for loop ends, and then you do that one. But in here, we've got 3 for loops, so that's even more complex. So just to go through it, we've got this function here, or this for loop, and then this function is called, and that generates a square randomly on the screen. And then we've got, I mean, not doesn't generate randomly, but generates a square at that position coordinate with the randomized color in the bluey green range. We then have a for loop underneath it that creates the for loop that creates the inner boxes. So these inner boxes here So when that runs, you then have a reducing amount, so you're reducing the size of each inner square, and then you have the function here that runs that creates the parameters for creating the inner square. So creating all squares is done with one function call. That's just one function that creates the outer square and all the inner squares inside of it. Now I'll make this code available so you can have a go with it. It did take me a bit of time to get all the crooks sorted out, but that's it. Alright, that covers, I believe that covers functions and loops. Yeah, I think for the next lesson we'll try covering classes and objects. Cool, I'll see you then. Alright, bye bye.